4.6, composition and inverse. These are just a couple concepts in terms of functions that wraps up chapter 4, really. The first one being composition. This is where we take a function of a function. So you're actually placing a function inside of another function. An example of this would be given two functions. So if we have f of x equals e to the x and g of x is equal to x minus 2, what is the composite function f of g of x? So what happens is we actually put g of x inside of f of x. In each of these cases, how you think of it is you're replacing each x in your f of x with the function g of x. So f of g of x, in this particular case, I'm sticking x minus 2 in the place of x in e to the x. So it becomes e to the x minus 2. What about g of f of x? So in this case, I would be taking e to the x and replacing the x in g of x with e to the x. So I would get e to the x minus a 2 on the outside. An example with a little bit more going on, if I give you f of x equals 2x plus 5 and g of x is 3x minus 2, then what is f of g of x in this case? Well, I'd take g of x and I'd stick it inside of my f of x, so the x that's being multiplied by 2 will now become 3x minus 2. So I'll have 2 times 3x minus 2, then add the 5 on the outside. Now, because this is a linear equation, we can simplify it. So I can distribute the 2 to get me 6x minus 4 plus the 5, or ultimately 6x minus 1. What about g of f of x? Now, what you're going to notice is g of f of x is not going to get me the same function. It didn't before, and it's not going to this time. So I plug in 2x plus 5, where my x is in the g of x equation 3 times x minus 2, so it becomes 3 times 2x plus 5 minus 2 to get me 6x plus 15 minus 2, or 6x plus 13 total. The other concept in this section is an inverse, which we talked a little bit about when I introduced exponentials and logarithms, because a logarithm is an inverse of an exponential. It reverses the function or undoes those operations. So we undo the operations in the opposite order, which means that if your f of x is 3x plus 5, then your x is, in this equation, being multiplied by 3, and then it adds 5. Right, that's what happens. If we invert this, then we undo those operations in the reverse order. So the last thing that we did was we added 5. So the first thing we'll do is subtract 5. And then, instead of to invert the multiplied by 3, we then divide by 3. So this function is our inverse of f. So we denote that with this minus 1 exponent to the f. So f minus 1 of x. And that function, right, if we subtract 5 from x and then we divide by 3, that looks just like this, x minus 5 divided by 3. That's our inverse for f of x equaling 3x plus 5. Generally speaking, you will only have an inverse function if your function, so f of inverse of y equals x, if and only if f of x equals y. So they're tied, right? You have to be able to actually solve for this f inverse of x function. How we do that algebraically generally, if it's not as simple as this first example where you can undo these operations more easily, algebraically, you can kind of do these in either order. They're the same things, just in one case I swap x and y first, and in the other case I swap an x and y at the end. Sometimes I find students like one way over the other way, so I've just written them both here. You start with your function, f of x equals y, and then you have the option of solving for x and then swapping your x and y to get your inverse function. Or you can swap x and y first and then solve for y, because that's something maybe you're more used to doing, and then that right there is your inverse function. So either is fine, because they're the same thing, you just have to be somewhat consistent. You only swap x and y once. That's the important thing. So if I give you f of x equals 3x plus 5, right, if we did this algebraically, we would write out y equals 3x plus 5 in both of those instances. For the case on the left, we just solve for x. So you subtract the 5, you divide by 3, and you get x is equal to y minus 5 over 3. And then to finish it, you have to flip-flop your x and your y to say that y is equal to x minus 5 over 3. Okay? The other way is you start by flipping them, and then you just solve for y, and then you're done. And you get it. Same operation, same function, and it should be the same function. It's just a matter of what you're more comfortable with, solving for x or solving for y. It's fine by me either way. In order for this inverse function to exist, you must have a function that is 1-to-1. This is an interesting concept, but I think that the easiest way to understand it is to recognize that it means that your function will pass both the horizontal and the vertical line tests. So to be a function, it already has to satisfy the vertical line test, which means that's done. The only thing you really have to check is, does it satisfy the horizontal line test, which is the same as the vertical line test, it's just a horizontal line. What that then says is that for each of the x values, there's only one y value, that's the vertical line test, and for each y value, there's only one x value, that's your horizontal line test. So if we had the function y equals x squared, that one is not 1-to-1 because it'll pass the vertical line test, but it does not pass the horizontal line test. So I sketched that in here. Right, if the green curve is x squared, the vertical line test, you're fine, but the horizontal line test, no, you pass through 2 points. And you can always check that. If it does not satisfy the horizontal line test, then it's not going to be 1-to-1, and you are not going to be able to define an inverse function for that particular function. You either have to restrict it, which takes some additional work, or it's just not possible. Do note at the end of this section, they talk about exponentials and logarithms being inverses of each other. That's how I introduced them. So I'm just making a side note to recognize that if your f of x is a to the x, that your f inverse of x is your logarithm base a of x. Right? That's the reason that they canceled each other all the time, is because they are inverses of each other. They undo each other. Okay?